Hi everybody, in this video we are going to see solution for a very interesting problem, that is best move for industrial robot. First of all, let's spend some time on understanding the problem and then we will discuss about the solution. In an industry, robots are employed to bring specific number of nuts N into its current location. Different number of nuts are packed in M packages and kept in rack at a location inside the industry. Robot can make only one fetch operation. The important point to notice, it can do only one fetch operation. So what's given in the problem is there are some racks, okay, there are racks and there are some packets of nuts. Each packet contains different number of nuts. So totally you want to fetch n number of nuts and there will be m packages. This is the understanding, okay, till now. And then you are going to make the robot to do it, and robot can make only one fetch operation. In a single fetch operation, they can fetch packages from one rack or more than one adjacent rack only, right? So it can take a particular package, one package, or it can take only adjacent packages. It cannot pick as it likes. Only one fetch operation should be there. Size of the fetch operation is the number of packages taken by the robot. Okay, so what is meant here is, so if it takes 2 packets, then the size is 2. If it is going to take 5 adjacent packages, then the size is going to be 5. Power consumed by the robot increases with the size of the fetch operation. So, will increase if it is going to take too many packages, right? Maybe like it has to, imagine like the arm has to be stretched more and so on. When fetch size is same, fetching from racks with lesser rack packets, right? For example, if the number of nuts required is 10, I have got a package like 6-4 and another 2 packages like 5-5. Either it can pick 6-4 or 5-5. That's the case that is being done here. When there are more than cases like this, the first one will be preferred because the nearest one will be preferred. That's what is given in the problem. So given the number of nuts required n, number of nuts in each of the m packages, write a code to print the number of nuts in the package that ought to be taken by the robot so that it consumes least power. That is the constraint. Okay, least power means you have to have these things in mind. If the number of nuts cannot be fetched, in some cases it cannot be fetched, in that case you have to print not possible. So for example, if the number of nuts required is 10, okay, if you want 10 nuts and then nuts are packaged as shown here, then how it picks is that you need 10, so it will take directly 10, okay. So because it says that it prefers the least number of packages to be taken, okay. So first preference is the least number of packages. If 10 is there directly, you will take it. And next case is it wants 18 nuts from the same set of packages. Here you see that none of the adjacent packages sum up to 18 actually. You can get 18. For example, if I take 10 and then 6 and then 2, I can get 18. 10 plus 6 plus 2. But they are not adjacent. We should remember that the robot can pick only the adjacent packages, right? So you have to consider the adjacent numbers. It's not possible. Okay, so let us bring the idea of solving the problem. The problem boils down to actually you will be having a list and you have to consider sub list of this list with adjacent elements only, right? For example, it's given 2, 3, 6, 4, 10. Okay, so sub list of 1 will be each individual element and sub list of 2 will be, I will have options like I can take 2 and 3 or 3 and 6 or 6 and 4 or 4 and 10. These are all the sub packages of size 2. And then sub packages of size 3, so 2, 3, 6 and then 3, 6, 4 and then 6, 4, 10, right? And then sub package of size 4 will be 2, 3, 6, 4 and 3, 6, 4, 10. These are all the 2 sub packages of size 4 and all these together will be the sub package of size 5, right? So we have to identify these sub packages and we have to sum it up and check whether it is equal to 18. This is a brute force method. I am not using any special packages of Python. I am just thinking about the basic idea of solving the problem with like list features, data structures like list and so on, right? Okay, so the idea is we have to enumerate these packages. Okay, first is of size 1. Size 1 is directly present. We can use a in operator and check whether that is directly present. For example, for the first case, we can use the in operator. 10 in this particular list will return the true, isn't it? In that case, you can print n. And if it is not directly present, then what we have to do is we have to generate the sublist of size 2. Start from the first position, right? You have to start from the first position and then you have to go, right? This is the basic idea. So we have to generate packages. Let's try to figure out the algorithm for this now. The first thing what you have to do is you have to generate all sub packages of size 2 to m, right? 2 to m we have to generate, and when we start generating, you have to start from index 0, that is the leftmost, and you have to go till the maximum possible. The maximum possible is m minus I. You have to go till m minus I, right? Because from this particular location you will be taking I elements, isn't it? So that will be the last possible position. For what I meant to say is, when you are generating sub packages of size 2, you will come till only 4, right? I cannot start from 10. Similarly, when I want to take sub package of size 3, I can start only from 6 in this particular case. 6, 4, 10 is the last sub package that I will generate of size 3. I should not go beyond 6, right? So I have to start from the leftmost index 0 and I will go till only m minus I. This is the idea. So I have to loop through. I need a nested loop to do this, and I will be checking whether the sub package is having the sum as n. If it is n, then I will print it, and if I could not find at all, then I have to print not possible. So let's write the rough algorithm. I have put it as a command. First step is read the value of n. So let us read it and convert it into integer. And next is you have to read the value of m. And next is the number of nuts in each of the packages. Okay, so let me tell nuts nut underscore packs, and it is going to be on a single line. When you read the input format, you can just understand that it will be in the single line separated by space. So we are going to use this comprehension for forming the list. So read the value as a string, use the split function. By default it will use space to split it, and it will give you a list. And then what you have to do is, for x, you take each element from this particular list and then you are going to convert it into a integer, right? Put it inside the list. This comprehension will help us to create a list of integers, right? And next is, okay, so everything is ready. Now we are going to check if n is present in n. That is the case of sub packages of size 2 or size 1. So if n, you can check nut packs, right? If I directly have a nut pack which is having n nuts, then what I can do is I can just print n, right? Otherwise, okay, otherwise, so you put a else. Then what you are going to do, you have to start from, I am going to now generate sub packs, okay, sub packages. So I have to start from the minimum possible thing, that is of size 2. 1 is already checked. I have to start from 2, and the maximum pack size, sub pack size can be n. I can use all the m packs to get the number of nuts also, right? Okay, so I am going to write a loop for I in range. This should be the outer loop, because as per the problem, the robot prefers smaller number of packs to be taken, right? So this must be the outer loop. You have to try out all the possibilities of size 2. Right, as per the constraint of the problem. So we make this as the outer loop. You have to start from 2 and you have to go till m. So I will put m plus 1 because of the nature of range. Range will generate 1 less than the second argument, right? And then what you are telling, you have to start from, now we are going to tell from next variable you are going to loop, right, j. So your j you tell for, you have to start from the leftmost position. Leftmost position is 0, and how far you have to go is, you have to go till the n minus ith pack, m minus ith, that's not n, sorry, m minus ith pack, right. So m minus I have to go till m minus I, means as per range I have to give m minus I plus 1, right. So you can write it and also see. So in this case what will happen, the j loop will start from the leftmost position and it will go till the last maximum possible thing, right. If you are going to take 2, I have to go last but 1. If you want to take packages, 3 packages at a time, you will go last but 2, right. Like that you are going to control the second loop, and then you are going to check if n value is equal to sum of the, now I have to consider the sub package, right. So I have to consider sum of NUT_PACK. So where you are going to start? You are going to start j. We are going to use slicing for this. You are going to start from j and you have to go j plus I. So this will give you the exact number of sub packages. You are checking whether the sum of that is equal to n. In that case what you will do is, you have to print all the values. So for Sn, okay, better I will put it as a separate thing so that I can name it. Let me have a sub packs. Let me tell sub pack equal to, I need not use sum here. Let me take the sub pack separately, and here I will tell sum of sub pack, okay, sub underscore pack, right, okay, right. And what I am going to do here for S and sub pack, I have to print each element in the sub pack, right. So I have to print S comma end equal to space. We have to print with spaces, that's what is given in the output format, and then we have to break. The point to be noted here is, that is I have identified the sub packages, that's the point, so I have to break it. Here it is in a nested loop. If I am merely giving a break, I will come out of only the inner loop. Actually I should not give break here, sorry. This break should be in alignment with the body of if, right. I should print all the elements in the sub package. This is fine. This print should be always done. Here, if this condition is satisfied, I should break. Okay. But see here, I have got a for loop controlled by I have got another one for loop controlled by j. When I am telling break, the innermost for loop only come broken, right? The outer loop will continue. I do not want that to happen, means then I need to have a variable here, right? Outer break, you tell outer break equal to, let me tell false, right. When it becomes true, I will break, okay. So outer break, if outer break, simply telling if outer break is equivalent to, if outer break equal to true. In this case, I will tell break. See here, this break is inside the, sorry, this should be inside the outer for loop, right. So here I will tell, yes. Okay, so when the outer for loop will break us when outer break is equal to true, right. First I make it as false so that the loop continues. If I have found the sub package, I will just print the elements in the sub package and I will break the inner loop by just telling break. Okay, how to intimate is, one more thing I have to do before I break, I have to tell outer break, outer for loop should also break. My job is completely done. So I will just tell outer break equal to true. This also I have to make before I break the inner for loop, right. Sorry. Right. So here, and when I come out of both the loop, right, when I come out of both the loop, I will tell not possible. When will I tell not possible is, if I couldn't find a sub package at all, right. How can I understand this? Based on my outer break. So if my outer break is still, false, then I can understand that I couldn't find a possible sub package at all, right? So in that case I will tell not possible. Actually in one case we can do else for this for loop, outer for loop, but what happens is this will not work for the case when I have to take all the sub package, all the packages, that is for example if the value of n is 10 and the value of m is also 10, and if you have got one in each of the package, then I have to pick all the adjacent packages to get the number of nuts. In that case, if we put a else for the for loop, it will not work. Okay, so please understand the else for this for loop we can add as per our idea. You may get into the get an idea like it will work, but the problem is if we have to pick all the sub packages, then it will not continue the loop. So it will not break, it will be a smooth exit, right? In that case your code will fail for that particular case, right? So whenever we are writing code, we should be very sure that it will pass all the test cases, all the corner cases we have to consider. If you are putting a else, then the corner case, like when you have to pick all the m packages to get n nuts, it will fail. So we are using this outer break variable to check whether you should print not possible or not, right? That's what we have done here. Let's run the code and check it. So when you are going to run, I was just checking all the possibilities. Let us take the example given here. Let me tell 10 and then 5 packages are there, 2, 3, 6, 2, 3, 6, 4, 10, right? So 10 is fine, it's working. Let me give 18 for the same case, 18 nuts I want from 5 packages, right? And each package contains 2, 3, 6, 4, 10, right? Let's say it's not possible, right? Now let's try the code in vPropel. So let's paste it and try. Yeah, it has passed. So you can also try. There are certain corner cases that you may have to try. You can write it on the notebook and check out the different test cases. Thank you.